Okay, Assalamualaikum and good afternoon. So today we continue our discussion on tutorial. So last tutorial I already upload in my YouTube. So I hope you could watch the tutorial. So and the most important thing is please try to solve that problem. Start from zero with your own calculation, because mathematics it's not for reading, it's actually the practical work. Okay, this is the question for tutorial for boundary layer number 7. So the question is simple. So let's say you have velocity profile of this one, u over u, y over delta to the power of 1 over 9. So you may write y over delta to the power of 1 over 9, or you could write eta to the power of 1 over 9. So, and then the question is, you need to calculate the value of CD. So please bear in mind that actually we have two types of coefficient. So you need to know the full terms. Okay, please do not just remember the CD or CF and so on and so forth. So normally in a question, we will give you the full term. So mean, for example, the local drag coefficient, or sometimes local skin coefficient. So means the word local there will reflect the word of C and small d. Okay, something like that. So and then if you have this velocity profile, so what you could do is, first, I hope you could understand that from the velocity profile itself, you could know that the condition is turbulent boundary layer, because this is the basic terms of velocity profile for turbulent boundary layer. So means that you need to know, you need to start your calculation by using von Karman equation, and also you need to make sure in the question you have Blasius resistance equation. So means that the value of shear stress given by the Blasius. So means this term will be given in your question. So if the condition is turbulent, please do not use shear stress from Newton's law of viscosity. So this is very important. The difference between laminar and turbulent boundary layer is, in laminar boundary layer, yes, you could use Newton law of viscosity, but for turbulent boundary layer, you need to do the value of shear stress by empirical method. So means by Blasius calculation. So means that from this situation, we know that it is a turbulent. So we prepare the von Karman equation and we prepare the shear stress value from the Blasius calculation. So what we need to do is we need to equalize both value. So from the von Karman equation, we have the value of theta here. So we calculate the value of theta. So I hope you already know how to calculate, how to determine the value of theta by using the boundary layer momentum thickness equation. So you will get 9 over 110 delta. So you substitute it here, and then you could simplify von Karman equation into this one. So and then we equalize with the Blasius resistance value here. So and then we need to solve, means that we need to calculate the value of delta. So here you could see that we have d delta dx. So we need to eliminate the differential form. So what we do is we need to integrate both sides. So the trick is we bring all the value, okay, to the right hand side, and we let the delta and d delta in the left hand side. So and then we integrate both sides, and finally you will get this value. So after you integrate, you will get this one. And again, please make sure that you could write the value of C, the constant of integration. So this will bring you marks actually, because it shows that you already know what happened in integral. the constant will comes out, and you determine the value of constant. You prove it by the calculation. So we substitute the value of u equal to 0, delta equal to 0, then we will get the value of c is equal to 0, and then finally we could simplify the value of delta here. Okay. So and then I just keep the calculation here. So this is the value of delta. So and then what you could do is the simple one. So the CD here is actually the 2 theta over L. So here we already know about the value of theta. So we could get the value of theta here. Okay. We have a 9 over 110 delta, and then the value of delta here is already calculated. So this is the value of delta. So you substitute in this one, so you will get the value of 0.0698 over Reynolds number to the power of 1 over 5. So please try this at home. So this is a very basic calculation. So in tutorial, in theoretical, in lecture part, so I already show you the 1/7 power law, means the turbulent boundary layer with the power of 1 over 7. So now in this tutorial, I show you with power of 1 over 9.